Hello everyone, welcome back to another video in the Let's Make a Game Engine series. I'm super excited to be back. We're going to jump right in. So, last time what we did, we set up our CMake build system and some basic structure in the project, and now we can run it. And we get hello from static library, which is perfect. So, today we're going to actually start on some basic things that the engine needs. First things first, we are going to create an OS file. So we need an os.h, and for now we're going to need an os_win32.c. So we'll need these. And we have to make sure that we always include these here. One. Also, before we can work on the OS layer, we have to create one more file, and this will be our defines.h. So this file. So what this file is going to be is where we make any macros we need to use, where we do platform detection, CPU detection, put any defines that we need throughout the whole project. That's what we're going to do with this file, and we will have another file where we make our type defs. But for now, we're going to stick to this one. I'm just going to add a comment. Okay, so we're going to, for now, all we need is some basic platform detection. So we're going to have an if def underscore win32 and an end if. Define. Xbox. So eventually I want to support Xbox, but I'm not going to worry about it right now since it's proprietary. So for now, this is our little platform detection. We only have Windows, and we're just going to define SL platform Windows for Starlight platform Windows. I don't know if we need anything else yet. We're going to need definitions for thread local, since we're going to be working on fibers, and we're going to need some other definitions, some macros, but for now I'll keep it like this. So we'll go into the OS. So here we're going to actually start showing how we're going to write code in this project. If you want a style guide, I like my directories to be uppercase, I like my files to be lowercase, and I like my APIs to be written in a C# kind of way, even though I'm writing in C, which I know is a little weird. So, for an example of how we're going to really make our project, I really enjoy the machinery blogs and the BitSquid engine blogs, and there's a lot of resources online. You can go on GitHub or the Wayback Machine, because our machinery took their blogs off the internet. But they have really cool design choices, and I think it leads to better code and more maintainable code. And I've been writing code as if I was a part of their team for a year now, because ever since I read their blog, I thought it was amazing. If you don't know, they have a few rules. One of their rules is header files cannot include other header files. So the only header files I'm going to allow to be included in other header files are going to be our defines.h and our API types, maybe some math types, very, very small headers, but other header files will not be allowed to be included. Another thing we're going to do is all of our API, well, most of the API will be written in C. And we will make all of our API structs with function pointers on the inside. And that might sound weird. It might sound like it's hard to debug. There's some drawbacks, but there's also some benefits, and it will really help us with our plugin system when we get there. So let me give you an example of what I mean and how it will work for the OS layer. So we will have a typedef struct, and we will call this OS thread API. And in here, you can have a function pointer to create thread. This is just an example. We're not going to really have this right now. And we got to make sure, since it's a typedef. So this is what our APIs will look like. We will have structs with function pointers. And for our foundational libraries, we will have a non-typedef struct where we include all of our other APIs. So for this one, we will have an OS API struct. And as you can see, I like writing these uppercase stylings just like C# because I think it leads to a more modern looking code base. I like the way it looks when you write a game in Unity. I like the way it looks when you write a game in Unreal Engine. And they all use the modern C++, C# style guides. So that's what we're going to do, even though we're writing files in C. If you're writing along in your own projects, feel free to do whatever you want. So we will have a struct OS API, and how this will work is this will include our other APIs. Pointers to other APIs. I do this, so more styling wise, lowercase when it's a variable, lowercase first, uppercase second word. I like to do it that way. It's really up to you. This is how I'm going to do it. So we'll have a bunch of APIs to keep it really separated, and then we'll have an overarching API that we will pass to other things. So how will this work? Well, we are going to use some macro shenanigans and do, so if a project links to the base library, which is basically only our executable projects, we will have an extern struct OS API pointer, and here we can give it a name. I'm gonna just call it the OS API, and that's how this will look. So when we link this file in the testbed application, this will compile. This will actually get compiled, and it will look for something else in a different object file getting compiled by the compiler to find this struct. And where this will be defined is inside of whichever platform we are in. So if we're in this file, and we do an ifdef platform Windows. So if we're in this file, what we will do is we'll take this, get rid of the extern, it's a reference to a static struct OS API, and the thread API will be equal to our threading API. Oh, almost switched to Win32 thread API. We don't need these. And then we'll have a static OS thread API, Win32 thread API, and then create create thread will be equal to win32 create thread. Actually, win32 create thread. And we'll, for example, we'll have a void win32 create thread up here, put it here. So how this will work. We'll write all our functions. We'll create static structs holding these functions, and then we'll have one huge struct that holds all of our other APIs. I don't know why this is this. We need this, I think. I don't know why this is showing up. Oh, we need a reference to this. And I think we can keep this comma since we're writing in C. So we will make our big API take a reference to a static API defined in this translation unit, in this compiled object. If you want to see this in action, we'll just say created a thread. So now everything's set up, at least for this test, and if we include os.h and we set target, we need compile definitions. Target compile definitions for this target, which is project name. We're going to make them private so that nothing else can take these definitions, and we're going to do links sl base. We'll reload CMake, and now if we go to main, what we will have is, instead of calling this test function, we will get our SL, our OS API, our thread API. We'll call create thread, and we will run it, and we created a thread. So this might look overly complicated. I know this can get, it can take some time to get used to. We're using a lot of these arrows since we're dealing with pointers, but let me show you a good thing that this comes with. Let's say we were to take our thread API and call it thread, a pointer, thread API pointer, and call it thread, and then we were to take this and set it equal to this. Say we had an initialize function and this was a global variable. We could set this global variable to this, and now we can just use this to clean up our code a little bit. You can build it. Everything works exactly the same. And even though it looks a little bit weird, like what is this? It's a pointer. And what is it a pointer to? It's a pointer to a static struct containing function pointers. It might be a little weird, but it gives us kind of like namespaces in the C language, and also it will help us create a huge global registry or manager of APIs. Why that's important is it will help us create our plugin system. Every plugin will just be a struct containing function pointers. So instead of some plugin systems where you have to have an update function, our plugin system will allow us to have a plugin that contains any amount of functions. Well, we'll give a max, but for example, any amount of functions that can do any amount of different things instead of just running on a loop. And that will be extremely powerful. Give me 1 second to see what we're going to do next. What we're going to do to end off this video, because I don't want it to take too long, is we're just going to do a little bit more platform detection in this defines.h folder. So we're going to start off with another ifdef. And we're going to be looking for a few things. we're going to look to see if we're using the Microsoft compiler, and we're going to make sure that we're not using Clang. I'm just going to make sure I got this in right, and then not defined. So the reason we're going to do this is because we need a little bit of a different setup depending on which compiler we're running. I'm going to be dealing with mostly Clang, but I do want this to work on most compilers, most meaning the Microsoft compiler, Clang, MinGW, if I can get that working. I think everything should work, but we'll have to see, and if anything comes up along the way, we will fix it. So I know for our base systems, we're going to need a few defines. We're going to need a thread local define, and for Microsoft's compiler, thread local is going to be a little bit different than the Clang compiler. So for thread local things, we will need to do this decal spec thread, and we're going to do an end if right here, and we're going to do an if defined underscore Clang or defined. I think we can do GNU right here. So if we're using Clang or the GNU compiler, we're going to define thread local as thread. I think that's what will work. Or define. What's this end if complaining about? I think that's just giving a false. I think we need to include a few things if we're using GNU and Clang. I'm going to just include a few things because usually I do this in my defines files when I'm dealing with Clang. I think this gets defined somewhere. We can actually check. Actually, we can't check. It doesn't want to show me. But anyway, I think it comes from systypes. I think that's where thread comes from. So we'll have this defined. We're going to need a few more. We're going to put an assertion, which will be slightly different for Clang than it is for MSVC. We're going to use the static assert macro. So down here, I think it's also different for GNU versus Clang. So we're going to do this. We're going to define a compile assert. So this assertion will be used during compile time. And I think it's static assert expression. This should be correct. I think there's always a problem. See, we need this. I think we need. Let me actually expression so it's more clear. I think this is what we need. Because it just turns into this. I think that'll work. We'll test it real quick. So let's go to our main file. Thread is undefined. Let's see if this builds. Okay, build finished. So it's complaining for no reason. Let's do compile assert 0 equals 1. Let's try to build this. And we got use of undeclared identifier. Okay. Maybe we don't use static assert. Okay, maybe we use just this. This is what that macro was supposed to turn into. So maybe we just do this. See if it builds. Static assert failed. Expect did... Oh. Okay, so the only error we get now is the static assert failed. Okay, cool. So our compiler asserts will work. Let's just get it ready for MSVC. I think for MSVC, I think we use the normal assert. Or that's where we use the macro. Okay. I'm just looking at a different file. If we're using MSVC, we're going to include this debug header, and we're going to define compile assert using this static assert macro that we used down here on accident. And then down here, this is if we're using GNU. I think we don't need this expression. Oh, actually, it's a different static assert on GNU. So it'll look like this. Okay, this is where I'm going to cut the video. Next video, we're going to work on getting some more defined setup and really working on the OS layer. I hope you guys enjoyed. Thanks for watching. See you in the next one.